Hi everybody, Ms. Lee here. Today we're going to be talking about derivatives of transcendental functions still, but now we're going to be talking about specifically the inverse trigonometric functions. Okay, so I'm going to write out each of the derivatives of the inverse trig functions. So we have first it's going to be arcsine. So I put arcsine of x. Sometimes when you see this written elsewhere, you might see this as sine inverse of x with a little -1. But I've found that students often get confused with this one, so I'll be using arcsine of x. This does not mean 1 over sine of x. This means sine inverse of x. So just an FYI there. So the derivative of arcsine of x is going to be 1 over square root of 1 minus x squared. And the derivative ddx of arccosine of x is going to be the same thing but negative. So it'll be -1 over square root of 1 minus x squared. And then ddx of arctangent of x, that's going to be 1 over 1 plus x squared. For arcsecant, arccotangent, and arccosecant, I'm not going to write them out because I'm not testing on these in my class. But if you look at your derivatives and integrals formula sheet, it will be on there. So if you ever need it for whatever reason, it is on your formula sheet. But since I don't test it in my class, I won't be going over those. Okay, so let's go over an example using one of these. Okay, so for example, we're going to find dy dx given that y equals arcsine of x times arccosine of x. So first things first, you want to identify what operation is going on. And so the biggest operation I see here is multiplication. So this is a product. So we're going to use the product rule. So if you remember the product rule, that's where we generally identify one is u and one is v, and we kind of go from there. So we'll identify that as u. And we'll identify this one as v. So we'll start by doing uv prime. So u we leave as is. So dy dx equals, and then u is arcsine of x times v prime. So the derivative of arccosine of x, which is written up here, so that'll be -1 over square root of 1 minus x squared. So this was u. This was v prime. And we're going to do plus the u prime, or u prime v. So we'll do u prime, which is the derivative of arcsine of x. That's written up there. So we have 1 over square root of 1 minus x squared, and then times v. So then just arccosine of x. Just to reiterate, this here was u prime, and this was v. And so this was our product rule. Let's go ahead and do one more example. For example, I want you to find the equation of the line tangent to y equals arctangent of x squared at x equals 1. So find the equation of the line tangent to y equals arctangent of x squared at x equals 1. You know that when we're doing tangent lines, we're supposed to find 3 things. So we start by finding the point, and then we'll find the slope, and then we'll write the line. So point would be plug in the x equals 1. So we have y of 1 equals arctangent of 1 squared, which is just arctangent of 1. You should remember your unit circle. So the question that you are supposed to ask yourself is tangent of what angle gets you 1? And so if you remember your unit circle and you remember that you're in AP calculus, and so you have to keep your everything in radian mode, you'll know that this would equal pi over 4. For those of us who are not confident, you can go ahead and use your calculator. And so when you use your calculator, first of all, you want to make sure you're in radian mode. And then you'll go ahead and do tangent inverse. So that's the little blue above the tangent. So it's second tangent. And so remember we said that -1 is the same thing as inverse. It's not 1 over tangent. It's tangent inverse of, and then it was 1. And then it gives you some decimal. I don't know what that decimal is. So I'm going to go ahead and type in pi over 4 and make sure those are the same. Yep, they're the same. Good enough for me. So the point is going to be 1 comma pi over 4. Now we want to find the slope. How do you find the slope? Well, we take the derivative of y equals arctangent of x squared. So the derivative is y prime equals, and the derivative of arctangent of something is 1 over 1 plus x squared. So we're kind of like covering this up. So it'll be 1 over 1 plus that something squared. And then we multiply by the derivative of x squared. Well, the derivative of x squared is 2x. And remember that something was the inside function. So that's that x squared right there. Okay, so this was the inside function. This was the inside function, and that was the derivative of it by the chain rule. Okay, so then we plug in 1, so y prime of 1 equals 1 over 1 plus 1 squared squared, and then times 2 times 1. And so we have 1 over, and then 1 squared squared is still just 1. So 1 over 1 plus 1, that's 1 over 2 times 2 equals 1 over 2 times 2. That's going to equal 1. And so then the slope is going to be 1. And so then we write our line. Remember, we write the line using y minus y1 equals m times x minus x1. And of course, the m is the slope. So we have y minus pi over 4 equals, and then we have 1 times x minus 1. Okay, and just to reiterate, this one came from over here. Pi over 4 came from that point. So it was x comma y. That was the point. And then the slope here came from the derivative and plugging in the value. Okay. So there we have it. Those are the derivatives of arcsine of x, arccosine of x, and arctangent of x, which are your inverse trig functions. Happy day!